So in Michaelis-Menten equation, one of the most important assumption is that ES complex is formed, and this ES complex reach a steady state after the start of the reaction after some time. So this after the steady state is reached, the enzyme substrate complex concentration doesn't change with time. So at the beginning there will be free substrate and free enzyme. So after the reaction is started, the enzyme and substrate will bind to give the enzyme substrate complex, but as the reaction progresses, the enzyme substrate complex will, some of them will degrade to product, and a stage will reach where the same amount of enzyme substrate complex is formed out of the enzyme and substrate is equal to the amount of enzyme substrate complex dissociated into enzyme and product, and as well as enzyme and substrate. So that stage where the enzyme substrate complex doesn't change with time is termed as the steady state. So at steady state, the rate of formation of enzyme substrate complex is proportional to the concentration of enzyme and proportional to the concentration of the substrate. So as it is a bimolecular reaction, we know the concentration of each of them affect the rate of the reaction. And if the rate of this forward reaction is K1, the rate of formation of enzyme substrate complex from enzyme and substrate is equal to K1 into E into S as written here. And at steady state, the enzyme substrate complex formed will be dissociated in two directions. So the rate of forward dissociation that will lead to the formation of product is dependent on this K2, so which is the rate limiting step. Of the reaction. So rate of the dissociation of ES complex towards product is given by K2 into ES, because ES complex is only it is taken as a single species, and the dissociation of ES complex to enzyme and product is solely dependent on enzyme and substrate complex concentration. So the rate of forward dissociation is K2 into ES, and similarly the rate of backward dissociation is K minus 1 into ES complex. So at steady state both will be equal. Hence the concentration of ES complex formed will be equal to the rate of its dissociation, so that the concentration of ES complex doesn't change with time.